So today we'll discuss a package called as java.io package, right? So the class is from this package and I'll be trying to understand today. So up to now we have written lots of programs for creating the classes and we compiled, we executed. But I think nowhere we have taken the inputs are apart from writing the outputs to a console, we did not write the outputs to any other locations, right? So till now, till date, we did not see anything like that, checking the inputs dynamically while your program is under execution and writing the outputs to some other locations apart from console, right? So today we'll see how to do these kind of activities, right? So how can you take the inputs dynamically while your program is under execution, and we'll see how to write the text to different destinations, right? So, so to do these operations, so whatever the input and output operations, whatever you want to perform, so Java has given some set of classes. Java has given some set of classes and interfaces, and all these classes and interfaces are placed inside a package called as IO package. So, right, so what is this IO package? What is this package contains? This is a package which contains predefined package which contains some set of classes and interfaces for performing input and output kind of operations. So there is no one single mechanism which is given for you to do the operations. No. So it has given us, Java has provided with some set of classes. It's not one single class or two classes, right? So to write to a destination or to read from a sources, it has provided a set of classes. There are some like 20 to 30 classes are given for us, and all classes helps us in doing the same kind of activities, right? So reading and writing. Why these many classes? Why these many classes are given for us, right? So there is a basic thing we need to understand before moving on to this, right? So as a programmer, when you write a program, right? So we can take the input from different physical devices, right? As example, like you can pass the input to your program from a keyboard. There is a standard device we have, or you can pass the input from a mouse, again one more standard device, or you can read the text from a file, right? So you can read the text from a object, you can read the text from a network location, or you can read the text from a buffer temporary memory locations. Like this you have different locations, right? So there are the program can read the data from different sources, input sources, physical devices, like as I described, right? So your program can read the data from a keyboard, your program can read the data from a file, it can read the data from a mouse, it can read the data from a object, right? Object is also a collection of data source. It can read the data from a temporary memory locations, we call as what, buffers. So there are different physical devices available for us from which a program can take the input. In the same way, if you want to write your output to different destinations, right? So we have different physical devices are available, right? So the basic the basic device which we use, standard device, is console. For our Java programs, we'll be using a console as our standard output device. Not only this one, you can write the output to a text file, you can write the output to a object, right? You can store the data into what, some kind of databases, right? So like this you have different physical devices are there for us for taking the data, in the same way for writing the data also. So because there are many physical devices are available to perform the operations on each and every physical device, right? Java has given us different classes, right? So each and every class is responsible, whatever the classes which are given as part of this package. There are not one or two classes you have. There are, as I told you, right? There are like 25 to 30 classes are there. More, still more classes. Why these many classes? Why not one or two classes, right? Because there are different physical devices are available for us, from which we can read the data and to which we can write the data. So Java has provided different classes representing different physical devices. That means if I want to take the data from a keyboard, there is a special class is given. If I want to write my data to a console, right, command prompt, there is a class is given. If I want to take the data from a file, if I want to write the data to a file, if I want to take the data from a temporary memory buffer, if I want to write the data to a buffer, if I want to read the data from a object, if I want to write the data to a object, right? So like this, for each and every source and destination, there are some classes are given for us, targeting to each and every common sources and destinations, whatever we use. For each and every source and each and every destination, Java people has given separate classes, right? And all these classes are kept inside a package called as java.io, right? The package name itself says what? Input and output. IO stands for input and output. So this is the package which contains the classes. Java input and output package contains the classes and interfaces to perform the operations like reading the data as well as writing the data from different sources and different destinations, right? So that is what we have here. Now if you see this package, so again it is a predefined package which we will see, which we will get here, and which is also you can see in the API. Where is it? API, Java API, yep. Right, so this is the API you have, and there you can see the class like a java.lang IO package. Now we are interested to see not lang here, IO. What is this? IO package. Now go through this. See here there are some set of interfaces and there are some set of classes. See here, there's a big list of classes you can see here, and all these classes, whatever the classes you see here, all classes performs, most of the classes, not all classes, most of the classes performs the reading operations and writing operations only. But each and every class is given for us for a different source and different target, right? So different devices are given for us, different classes are given for us for reading the data from different sources and writing the data to what? Different destinations, right? Excuse me. right? So if you see these classes, there is a big list of classes are there, and each and every class is given for us for taking the data from different sources and writing the data to different destinations, right? So we'll come to these classes later, right? So generally, Java performs these input operations and output operations by using a simple concept called as what? Stream. It uses streams. So what is the meaning of a stream? A general meaning, right? A stream is nothing but a water stream if you take, text stream if you take, a continuous flow, right? So a stream is nothing but here we can take a continuous flow of data from a source to destination, right? So Java performs these operations, reading and writing operations through what? Streams, right? So that is what we have here. So let's suppose if I take a source, right? If I take a source, from a source, Java reads the data, Java program reads the data, or to a destination, it writes the data, right? So by opening a simple stream, so what it is going to do here, if you want to read and write, if you want to perform many operations, read operations or write operations, so these will be performed by opening a stream. So like this, it is going to open a stream with this source to read, right? So like this, it is opens a stream, right? Then once the stream is opened, in between your source file and that target, in between your Java class and that source, then it can read the data, right? So first, this is what a stream is, a continuous flow of data, I can say, in between source and destination. Now from your Java file also, if you want to write the data, so this is what reading. So your Java class can read the data. So a Java class can read data from source, or it can write the data to some destination by opening a stream. So a stream is nothing but a continuous flow of data from source to a destination. So it is kind of pipe in between your sources and destinations. So Java programs uses streams to read or write operations, to perform read or write operations, right? So very simple definition here, right? So what is the meaning of this? So if you want to read the data from a source, first from your class you need to open a stream to that particular source, or from your class if you want to write the data to your destination, first you need to open a stream. Once the stream is opened, then only through that stream you can pass the data, otherwise it is not possible. Directly writing is not possible, right? So first you need to open a stream for reading or writing, anything if you want to do. You need to open a stream to that particular source or destination. Once the stream is opened, then only you can read or write, otherwise you cannot perform the operations, right? Now that is what we have here, very simple here. So first you need to open a stream, then only you can perform read and write operations, right? So there are two different type of streams are defined, two categories of streams are defined for us, right? So what are the two different categories of streams we have here? So Java performs this in writing operations or reading operations, right, in the form of byte streams. What they are? Byte streams. And the second category you have what? Character streams. These are not classes, two categories. Character streams. So it performs operations in two different ways, I can say. One is by using with the help of what? Byte streams, or in the form of what? Character streams. What is the meaning of in the form of byte streams? Nothing is there. So the read and write operations, whatever the operations we are saying, read and write operations will be, read operations or write operations will be performed, by using what? Bytes. It is going to perform the read and write operations in the form of what? Bytes. They are called as what? Byte streams. So there are all a number of classes are there, as I told you, not one or two classes. Targeting to different sources and destinations, different classes are given. But all classes purpose is same, reading and writing. Right? So simple. Now in the same way, there are few classes are given for us. They perform again read and write operations. Again, this class also perform read and write operations. And but these classes perform the read and write operations with the help of in the form of what? Characters. They use characters. So the data will be transmitted in the form of characters when you use the character stream classes, and when you use the byte stream classes, the data will be transmitted in between source and destination in the form of what? Characters. That is the only difference, nothing more. Right? So the difference is what? The difference is the data, the flow of data. So the flow of data, if you use the classes of byte stream classes, the flow of data will be in the form of bytes. Reading and writing will be done in the form of what? Bytes. And if you use the classes which are belongs to what? Character streams, the data flow will be in the form of what? Characters. Getting me what I'm trying to explain here? So it is very simple. As a programmer, it is very simple to understand. This theory is very important to understand. So as a programmer, if you want to perform the operations, in Java for reading and writing the data, so Java defines some set of classes inside a package called as what? IO package. Right? There are two different category of classes you have: byte stream classes, character stream classes. If you use the byte stream classes to perform reading and writing operations, the data will be transmitted in between. The data will be transmitted in the form of what? Bytes. If you use the classes of what? Character stream. If you use the character stream classes, the operations, read and write operations, will be performed by transferring the data in the form of what? Characters. That is the difference we have. Right? So just the data, passing the data in between source and destination will be in the form of bytes and in the form of characters. So those are the data which is the classes which helps us to read and write the data in the form of characters. They are called as character streams. The classes which helps us to read and write the data in the form of bytes is called as what? Byte streams. Right? So we'll see the classes here, which classes are part of which one. Now this hierarchy is very important. But whatever the classes you have, all classes, the basic thing is only two important things you need to remember here while writing the program. First thing is you need to, according to your source or according to your destination, as we discussed, there is appropriate class is given. You need to use that appropriate class to write or read by opening a stream. That's it. So if you are trying to read from a file, so through a Java program, you need to open a stream to a file, and through that first stream you can read it. If you want to write to a file from a Java program, you need to open a stream to what? File, and you need to write the data from that stream. If I want to read from a keyboard, yes, from a Java program, you need to open a stream to keyboard. From that stream you can read the data. If you want to write to a console, yes, you need to open that. If you want to write from buffers, same thing. You need to open the streams. That is the only thing you need to do, right? So we have, as I discussed here, we have byte streams. So this is not a class, this is a category, byte stream, right? So in the byte streams, we have two different type of classes. The classes which are responsible for what? The classes which are responsible for reading the data, right? And the classes which are responsible for what? Writing the data. Different classes are given. Reading some separate classes, writing some separate classes, right? So there is one super class is given, base class I can say, which acts like and one super class which acts as for reading operations. The class name is input stream. Again, in a simple inheritance is inside this. So there is one class is given. This class and its child classes, right? This class and its child classes are used to read the data from different sources. What is this class? Input stream. And this class and its child classes, all classes, whatever you have, child classes for this, all are used to read the data from different sources, right? So we'll try to see this class first. What is that? Input stream. And this is an abstract class. This is an abstract class, input stream. See, public class, public abstract class input stream extends object. Again, all fundamental what inheritance. So this abstract class is a super class for all classes representing what? All the classes which are representing input stream of bytes. Right? That means this class and its child classes all are used to read the data in the form of what? Bytes. There are different child classes we have, right? So here also you can create your own child class for this if you want to have, absolutely no problem, easy to extend, right? So you can absolutely free to create a child class for this class. Right? So when we talk about abstract class, right? So we have seen that it is always possible that it may contain what? Some abstract methods. Let us see here what is the abstract method inside this. So it is having constructor here. Yes, abstract class can have constructor and some set of methods are there. So a superclass methods, again fundamental inheritance loop. Whatever the methods are there inside a superclass, all these methods can be called through child class objects. And if you see this, there is one interesting method which is abstract. What is the meaning of this? Each and every child class of this class should override this method compulsory. And remaining methods also they can override, but they are optional. But this method should compulsory override. Let's suppose if I create a child class for this superclass, abstract superclass input stream, what I should do? My class must override this method, so that I can guarantee that this method will be there in each and every child class, right? So let me copy this syntax. So what it is? Now there is a read method which is abstract inside this class, right? So which is abstract inside this class. Now, so what is the meaning of this? I will explain later. Now there are few child classes which are given for this child class. This class has different child classes, right? So this is a class which has some different child classes, and each and every child class will have what you can guarantee. Now each and every child class must override this abstract method. So this abstract method syntax is what? Read, and which gives the data in the form of what? Integers, right? So let us try to see what subclasses are there for this, right? I'm not going to describe all subclasses, right? We'll see some few subclasses here which are there for this class, right? Now I can see here in the API, right? So these are all the direct known subclasses. These are all direct known subclasses for this. See, what is this class? What is this class can do for you? This class is a special class which is given to read the data from what? Files, right? This class is a special class which is used to read the data from file. Object input stream to read the data from what? Objects, right? So filter input stream, this is one important class which has some other classes, right? Data input stream is a one more important class, right? Buffered input stream is a one more important class. See here how many input stream classes are there. All stream classes are for theme. I'm just writing some few of the classes here, right? So first class is what is that? Byte array input stream. What is the purpose of this? It is going to read the data from byte array. It is going to read, this class helps us to read the data from array of bytes, right? So like this we have one more most important class very regularly we use, file input stream. So this class will have, this class is also used to this class is used to read the data from files. If you want to read the data from files here, and one more class, right? Filter input stream. This is a different class you have, which has some other child classes. This trgam, right? So this class has its own child. This class has some child classes like a buffer input stream. What is the meaning of this? So this class helps you to read the data from temporary memory locations. We call them as what? Buffers. Right? This has one more important class, data input stream. What is the meaning of this class? We'll see later. Input stream. Right? And you have object input stream, which is a child class of this one, I think. No, again this is a child class of filter input stream. Object input stream. No, where is it? Yeah, it is here. Object input stream direct child class for this one. Now, by seeing these classes, what you can guarantee here? What you can guarantee here? So all these classes, whatever the class I have given, still you have a big list of classes. All these classes are used to read the data only. And each and every class has a method. Each and every class will have a method. What is that method? Read method. See how easy it is. Arranging your classes in this hierarchy is very simple, because all these classes will have a common method. What is the common method? Each and every class will have. So this is the class. So you can definitely guarantee that. Why this method has made as abstract? That is the first question. Why this method made as abstract in the input stream? Right? So why this method has made as abstract in the input stream class? Very important and very simple to give the answer, because different classes, right? So different classes can read the data in different ways. So different classes will read the data in different ways. That means how I read the data from a file will be different from how I read the data from buffer, how I read the data from what? A object, definitely. So in the superclass, this is a common method. So this is a common method. Read method is the common method for all and each and every class. But that is the reason why this method is taken as part of superclass. But they cannot define. It is not possible to define a common behavior for this, because this read method will be different from each and every child class. So this read method compulsory, right? This read method should be compulsory implemented by each and every child class. If you create your own child class, let's suppose I want to read the data from some location, hard disk. Now I'm going to create a child class, hard disk input stream, extends input stream. And I need to, what I need to do? I need to override the read method. Absolutely, I need to override the read method. There is no option left. So it is very simple here. These are all classes. And all these classes on each and every class, I can call a method called as what? Read method. I don't bother how this read method is internally working. I don't bother. As a programmer, I will know that what I'm going to what I will know here. There are few classes are given, right, for reading the data from different sources, and all classes can read the data from the source by using this method. Each and every class can read the data from any source by using this method, right or not? File input stream, yes, this class will have this method. Buffer input stream, definitely this class also will have this method. Data input stream, this class also will have this method compulsory. Object input stream, definitely this class also will have this method compulsory. I don't bother about what? The class. On what class I am using this method. If it is a child class for input stream, I can blindly create an object for what? That class, and I can call this read method, which is going to read the data for me. That is the importance of what? Inheritance. See, abstract classes, right? So in the future, let's suppose one more class is added to this hierarchy. In the future, let us suppose one more class is added to this hierarchy. Now what you can guarantee that? 100% you can guarantee that through the object of that new class, I can call a read method, and it is going to return me the data in the form of what? Integers. Yes or no? It's very simple. So there is one method which is given for us, so you can simply remember, right? So there is one method which is given for us to read the data from any physical device, and that method is a read method which returns the data in the form of what? Integers. Very simple. Yes or no? It's very simple. I don't bother about whether I'm trying to read from a file, whether I'm trying to read from an object, whether I'm trying to read from a keyboard, or whether I'm trying to read from some buffer. I don't bother, because all classes has a common method called as read method, and I can call simply this method. Very simple. So changing the class, just changing the class from file to buffer, then your read mechanism will be changes. Simple, right? In the same way, there is one more class is given in this byte streams, right? So in the byte streams, there is one more class is given as a super class to write the data to different locations, right? So what is that class here you have, which helps us to write the data from to different locations? That class is, right, output stream, input stream and output stream. Same way how this input stream is abstract class, in the same way output stream class also what? Abstract class. And this class is used to write the data to what? Different destinations. This class and its child classes, this output stream class and its child classes are used to write the data to different destinations, not different. Now what is this class? Let us try to see this class. But output stream, where is it? Where is it? Yeah, output stream. Right? So what is this? Again abstract class. Output stream extends object. This abstract class is a superclass for all the classes representing an output stream of bytes. Output stream of bytes. So this class and its child classes tries to open a stream to some destinations, and through that stream this class and its child classes writes the data to those destinations. Right? So what classes you have here? In the same way, how we have different classes representing different sources, for each and every source, almost all, for each and every source class which is input stream class, there is appropriate output stream class is available. If I am able to read the data from a byte, I can write the data to a byte, right? So byte array input stream, in the same way you have byte array output stream. Byte array input stream and byte array output stream. So input streams are the classes which are responsible for what? Reading. Output streams are the classes which are responsible for what? Writing. Oh, I forgot, right? Then why this class is abstract class? We'll search for this method, right? See this? This is a method which is abstract in this class, right? So what is this method can do for you? This method is given for us, so which is going to write the data to what? Different destinations. This is going to write the data to different destinations. It is what this method is going to do for you. Right? So this is the abstract method. So writes the data to the destinations. So this, see this method is taking, if you observe these methods, so this method is taking some input, and this input will be returned to what? The target. Whatever the input you give to this method, and that input should be in the form of what? Integer. So whatever the input you pass to this method, this in the form of integer, it is going to write that to destination, the data to destination. If you see this, because I am reading, so no input should be given. So it reads the data and it will give the data to us in the form of what? Integers. Right? So one method takes the data from you, from your program, and writes it to a destination. One method will not take any data, but it gives the data to you. See the return types and parameters, when to take parameters, when to take return types, right? So very simple here. Now here in the same way you have file input stream, file output stream, class per file. Lots of classes are there, but I am not describing each and every one. Just I'm showing you to understand the hierarchy. File output stream. The same way you have the classes like what? Filter output stream. You're getting a simple inheritance inside this. As I told you, object orientation everywhere. Filter input stream, it has two child classes called as buffer output stream, buffer output stream, buffer output stream, right? So it has lots of child classes again, but I'm making data output stream. Is it there? Let me check. I have a doubt whether it is there or not. Data output stream, data output stream, filter output stream. Yes, you have okay. Data output stream, it is there. Fine. Buffered, it is not buffer, it is buffered, right? It is not buffer, buffered. Here also buffered input stream. Now then you have object output stream. Still lot more classes are there. Object output stream. Object output stream. So these are the classes which are responsible for writing the data to different sources. Like this you have different classes. Don't assume only these classes are present. No. There are different classes are there for you to write the data. Now according to your need, to which destination you want to write the data, according to that you need to pick the class. According to your source you need to pick the class from this. So right, so you might have understood. Now if I want to perform the operations on files, let us suppose if I want to perform the operations on files, there is a one class is given which tries to read the data from a file, and there is one class given which tries to write the data to a file. File input stream and file output stream. Right? So buffered input stream, buffered output stream, not buffering here. To write the data from temporary memory, to write and read the data from what? Temporary memory locations. There is no difference here. What is the difference here? I can say what? Simple class name is changed. But if I want to read the data from a file, or if I want to read the data from a buffer, I'm going to use the same method, read method. If I want to write the data to a file, or if I want to write the data to a buffer, I'm going to use the same method, write method, because this method will be there in this write method, and these read methods are present in each and every class. Getting me? That is the beauty of inheritance and abstract classes. So as a programmer, it's not a complex, it is very simple. Now whenever I say read the data from a source, then first thing is there is a read method which I can use to read. There are few more read methods are there, but this is the compulsory method. And there is a write method which I can use to write the data to what? Different destinations. Right? So are you able to follow me what I'm trying to say here? Yes or no? Are you able to follow me, guys? Yes. Yes, fine. So these are the different classes which are given for us to write and read the data in the form of what? Bytes. These are called as byte streams, but this is not a class, right? Byte streams is not a class, a category. Right? In the same way, you have one more category where the operations can be performed in the form of what? Where the operations can be performed in the form of character data. Right? What are those classes then? Those classes also present in the same, right? So we call them as what? Character streams. These character streams are not there in the initial release of Java. They are added in 1.2, Java 1.2, Java 2 version, right? 1.2 version. So in the initial releases, there only you have what? Byte streams. So in the same way, In the character streams also two different types of classes we get. The classes which are used to read and the classes which are used to use it for writing. The same way how we have seen the classes in the byte streams to read and write, in the same way you have the classes for in the byte streams. So again in these character streams also we have one superclass. That class is which performs the reading operations. That class we call as reader class. Right? What is this class? Reader is an same abstract superclass which is used to perform read the data in the form of characters. Abstract class reader extends object. Right? So abstract class for reading character streams. Abstract class for reading the character streams. Nothing is there. Again, so there are two different kinds of classes which given for us. Some classes will do reading operations in the form of what? Characters. And again, the same operation can be performed by using some classes in the form of what? Bytes. Right? So what is this method abstract inside this? So these character streams are faster than byte streams. So this is the abstract method we have, which is going to perform the read operation. Right? Copy this. It is the abstract method. So this is the abstract method we have, which is going to perform the read method, which is going to take the data in the form of characters, some character array, right? Starting position and how much data. But interestingly, yes, this is abstract method, absolutely fine. But if you see this, whatever the method up to now we have discussed, this method is also present. Read, but it is not abstract. So this method is still there inside what? Character streams. Whatever the method we have seen as abstract method inside byte streams, the same method is present. Read, which gives the data in the form of what? Int. So I can use this method for any streams. That read method I can use for any type of streams, right? So whether I'm performing the operations by using byte streams or whether I'm performing the operations by using character streams. Right? This is what? Same thing. So each and every subclass will have this read method compulsory. And if you want to read the data, you can go with this or the previous method also, whatever we have discussed. Though that is not abstract, that is also there inside character streams. Now what you have here, readers, same, right? So there are some reader classes which perform the operations in the form of what? Characters. Character array reader. Right? Character array reader, same here. I think you have same, almost all similar classes you find in this also. Filter reader, where is it? Filter reader. Same, whatever you have the classes inside bytes. File reader. What is this class? What is the difference you have between file reader and file input stream? Simple difference. One reads the data in the form of bytes. One reads the data in the form of characters. Buffered reader. Data input stream reader. No, you don't have a data input stream reader. I think filter reader. Where are its child classes? Okay. No, this filter reader does not have any child classes. Buffered reader is a direct subclass for reader. Okay, sorry, that is wrong. Buffer reader is a child class for what? It is same character array. Buffer reader, filter reader, input stream reader. It has file reader. Okay, fine. Some hierarchy of classes are there. It is not subclass of this. This is it is one class, and this file reader is a subclass of input stream reader or input reader. stream reader, and it is subclass of this. So whatever the classes you see, all are there here. In the same way, there is one superclass for this. What is that class? Can you name it? For writing operations. What is that class which is given for us for writing the operations? Writer. Right. So what is this class again? Writes the data in the form of character streams. You have different classes to write also. Buffered writer, filter writer, output stream writer, print writer. One of the most important class I forgot to give. Right. So but the difference is what? Same. So whatever you have here, all are present. Whatever you see here, everything is there. And the same way you have the classes character array writer. I don't think, right? So character array writer. Character array writer you have, sorry, C is capital. Input stream writer, right? In the same way you have input stream writer and all. Each and every output stream writer, not input stream writer, output stream writer. File reader, file writer. So whatever it might be the class used for writing operations. Filter writer. I'm not going to discuss all the classes, right? Buffered writer. Now what method is there which is abstract method which is going to perform all these operations for you? There is abstract write method. Oh, there are more abstract methods here. But there is one write method which is going to do this write operation. Copy this and here. Right? So this is what? This is an abstract method we have here. So whatever it might be the output stream or input stream or reader or writer, all classes performs common operations called as what? Reading and writing operations. Depends on the class, readers and writers, methods are changed, that's it. But every class is responsible for doing only the same operations, right? So previously we have seen file readers, previously we have seen file input stream, and in the same way you have file reader. Both are performing the reading operations in the files. There you have file output stream, here you have file writer. Both are used to perform the operations on files only. Writing operations on what? Files. Right? So but the difference is the way they perform the operations is different. These classes readers and writers uses characters to read and write. So those classes uses bytes to read and write. Very simple. That is the difference. Now how can I differentiate? How should I know? Out of all these many classes, how should I differentiate which are readers, which are writers, and which are input streams, which are output streams? How can I differentiate which are readers, which are writers, and which are input streams, which are output streams? That is called as what? Standards. Every reader class will have a postfix with what? Suffix. Reader. Every writer class will have a suffix postfix as writer. And every input stream class has a input stream, and every output stream class will have a output stream. File input stream, file output stream, buffered input stream, buffered output stream, like this. That is how we can simply use. So this is fine here, right? So this is how we are going to, this is the architecture of classes you have. And in this architecture you can see, right? So there is one common method for writing. Write method in the byte streams or in the character streams. You have one method for writing. What is that? Write which takes the integer. In both streams you have. In the same way, in bytes, reading, there is one common method which reads the data. That is what? Read method which reads the data and gives you the data in the form of what? Integers. Right? So now whatever it might be the stream, right? So that depends on your requirement, which class I need to use out of all. Which class I need to use out of all. right? Now let's see here. Then let me write one simple program so that I would like to read the data from a file, right? So public class, what is my intention? I would like to read from a file. So what I need to do first, if I want to read from a file as a programmer, first you need to identify the class which is given for you to perform what? Read operations on a file. There are two classes which are given for you to perform reading operations on a file. What are the two classes? One is file reader, one is file input stream. That's your choice. Which class you want to take, that's absolutely your choice. File reader is the best one because operations will be faster. The data flow will be faster because it passes the data in the form of what? Characters, right? So I'm taking one simple class here. What is the class here? What is my operation? File read example. My class name is file read example, right? Now what is the class which helps me to do this reading operations on the files? What is the class which helps me to perform these operations, right? So that is, as a programmer, you need to define, right? So the class is file input stream. I'm taking a file input stream. Right? Now some object I'm going to create. Simple. If you want to create object for a class, you need to check what constructors are there in that class. What is the class I would like to use here? File input stream, because I'm performing the file operations, right? Oh, there is no constructor without arguments. There is all constructors which are there, there are three constructors, each and every constructor takes an argument. Now I would like to use this one. What is this? File input stream constructor which takes a string argument. Yesterday we have seen. So how can I create the object for this? New file input stream which takes a string argument. Now from what file I want to read? Let's suppose I would like to read from the same source file where I am writing. What is my source file? Read example. Same. Whatever the Java file I am writing, from the same I want to read. Getting me? So because I am using the class from a package called as IO package, this class belongs to IO package, I need to import it. Otherwise you cannot use these classes. All fundamental rules, syntactical rules only I'm giving. So let me save my program with name file read dot example dot Java. Don't take the predefined class names as your class names. Never take the predefined class names as your class names. What happened? Where is my class gone? This is my class name, right? File read example. That's it. So what is the meaning of this statement here? As I told you previously, when beginning of this class, I told you, like, if you want to do reading and writing operations, first you need to open a stream to that particular physical device. Now nothing is there. Opening a stream means what? Creating an object for that particular class. Right? That is the meaning of opening a stream. Creating an object. It is not a complex task. So what I am trying to do here, when this object is created, file input stream object is created, now it tries to open a stream with this particular file. It tries to open a stream with this particular file called as read read dot example. Or let us take, so you can read from any location, absolutely fine, but you need to pass entire location path. Now if I want to read the data from a current location, so I am going to pass the file which is there in my current location, a.java. There is a file inside my same location where this class is there. In the same location there is a file called as a.java. But this class throws you an exception. This method throws you an exception, checked exception. If the file is there, this class can read it. But if the file is not there, this class cannot help you. So this method is saying what? If the file is not there, I cannot help you. That exception is called as what? IO, file not found exception. Throws file not yesterday's concept found. It is a checked exception thrown by that constructor. You need to handle it or you need to throw it. Because I am not interested to handle it. Actually, this is not the correct thing here, right? If you don't do this, your compiler will not allow you to compile this. So I would like to handle this by using a try and catches, right? So this syntax, whatever that statement I have used, which throws an exception, checked exception. If file is not there, I cannot help you. File not found exception. What is that class what is that object which throws for you? File not found exception. So I'm going to write system dot out dot println of file is not there. Something I'm going to write message. Specified file is not there. Simple. So what is this? What is this statement is going to do for you? This is the statement which is going to open a stream with a file, text file called as what? A.java. If the stream is successfully opened, then I can read the data from this file. The stream is not opened successfully, I cannot read it. Right? So what method I should call to read the data from that file? What is the method I should call to read the data from that file? Absolutely, there is a method called as read method. Right? Simple. File input stream dot read, and which gives the data in the form of what? An integer. This is what we have seen. It's an abstract method, and this method is there inside all its child classes, and this class also will have this read method. I am using the same method, right or not? Which gives the data in the form of what? Integer. Just I am calling a method from a class, and definitely this method will be there because this file input stream is a child class for input stream, and in the input stream class this method is abstract. Definitely this class has this method. 100% this class will have this method, right? That is it. So which gives the data. If this a.java is having multiple text, how it can be stored in one integer? Not possible, right? It's not possible. If I want to read, so if I print this, what it is going to give me? System data out dot println. This statement reads only the first character. This statement reads only the first character. It will not read the entire file. The statement will read only the first character, will not read the entire file. But we'll try to compile this program first. Right, so what is that? Java C file read. Oh, very interesting. Is cannot find symbol println. This will not be compiled. Yes, as expected. See again. But okay, if the file is open, that's fine. But if the Java runtime cannot read, Java software cannot read that file, the text, if it is unable to read it, then I cannot help you. So it is also saying what? I'm going to throw you one more exception. That is what? Which method? Read method is throwing the exception to its caller. Who is its caller? Main method. And the exception which is thrown to its caller is IO exception. Because this exception is not handled, the compiler is not allowing to do this. So you should handle all the exceptions. Right? What is this now here? This is IO. file cannot be read. File cannot be read. Simple. Now let me run because I have added. This is fine now. It's compiled. Now Java space file read. But it is not read entire file. See? And the data interestingly is given in the form of what? Integers. So what I have here? This is the file, actual file which I am trying to read. What I have? Class A, something, something, very simple class. Now let me compile again and execute. 99. Why it has given 99? It is giving the data in the form of what? ASCII values. Now if you want to get actual character here, you need to downcast it to what? Character type. This read method is reading only one character at a time, not reading the entire data. C. Why C? First character of that A.java is what? C. Now if I want to read entire file, what should I do here? Right? What should I do? I need to put inside what? While loop. Because I want to read the entire file. I need to put the while loop. Getting me what I'm trying to do here? In the while I'm writing means what happens if I write while true? It never comes out and it keeps on reading the file. I want to read entire file. So is the reason why I'm putting in while loop. Each time it is going to read what? One character. Each time it is going to read one character. Yes or no? fin dot read is going to do what? First time it is going to read automatically. It is going to first time it reads C. When the while loop starts again, it reads A. It positions it places a cursor. I can say first before C it is read, then L A S S like this. It is going to read it. But it never comes out because if I write true, it never comes out. Then there should be a condition where my while loop should come out, right? So when it reaches to end of file, this end of file is represented with -1 in Java. When it is -1, when I becomes -1, then stop reading. Getting me? Right? So what is this logic here? First I am trying to read the data before entering into the file. I am trying to read the data. If there is no content, then it will not enter into the while loop. But if there is a content and it compares with this and enters in, right, and it prints the first character, it prints what? The first character. Once the first character is read, then it is going to read what? Second character. And again after reading it, it is going to check whether it is -1 or not. No, print it. Like this entirely it is going to read the file. And once the file reaches to end, it will be I will be returning you what? -1. -1 is equal to -1. No. It should be not equals. Right? I becomes what? -1. -1 not equals to -1. Read it. So -1 not equals to -1 means what? False. When the condition false here, it comes out. Getting me? Now let me run this. Oh. It has read the complete file, but I am using println. That is the reason why output is printed in. See? Okay. This is the text. Is it the text I have inside that a.java file? Yes or no? What is the text I have inside a.java file? Same text, right? Class A, public void method, class B. Same text is printed. Are you following me? What I am trying to do here? Nothing I am doing here. A simple while loop I used. Because each time this read method can read you only one character. It cannot read entire data. So if I want to read the entire data, definitely I need to use continuously the same read method I need to use. So I have taken a loop and I need to stop this reading when the file reaches to end, and that reaches to end will be represented with what? -1. But before entering into this file itself, I am reading the first character. I am validating with what? Whether it is -1 or not. If it is -1, then it will not enter. If it is not -1, then it will enter. Right? So you can see. And it reads the data always in the form of integers. Then while you print it, you need to downcast it to what? Characters. Simple loop here. Simple logic, no complex logic. So right, so this statement is going to open the stream with a file called as a.java, and through that stream this statement read what? Byte by byte. This statement reads the byte by byte, and I'm just printing it. Can I change it to a file reader? Yes, absolutely you can make it as a file reader, because file reader also has this method. Change it to file reader, it works. Absolutely it works, because file reader also has the same method. Yes, file reader is also having the same method. It is going to print the same output for you, but different class, same output. Right or wrong? Right, simple modifications can do for you. Yes or no? Yes. Now what I want to do here is, now if I want to read this file, see this, what is this file? It is a big file. No, it is a very big file, index.html. Now what need to do here? It is there inside C. You need to pass the entire path. But right, you need to pass the entire path here to read that file. C users administrator desktop, like this. Let's see. It's a big file. It takes huge time to read it. You can see only the source of that HTML. You cannot see the API. This is the source you have. This is the file which I am able to read from desktop. Now what I want to do here is, what I want to do here is, now see this, what I want to do here is, anyways I am reading this file here, index.html. okay. Now this file I want to write this file. I want to read and I want to write the same file to some other file. Nothing but copy and paste kind of thing. Assume this. Read from one file and write it to some other file. Now what should I do in this case now? What my intention? I want to read from this file and I want to write it to some other file. So anyway, reading code I have written. Now what should I do to write the text to some other file? Come on. It's fine. Use write code means how to write it. What is that code I am asking? This is the read code I have. How to write the text to a file? Just simple, very simple. No, 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 no. This class helps you to read only. File input stream is helps you to read only. It cannot do writing operation. This is input stream class. Can perform only reading operations. There are some separate classes are given for us for performing what? Writing operations. What is it? File output stream. This is the class which is responsible for what? Writing output stream operations. F out. Create the object. New file output stream. Let's suppose I want to write it to file called as my html.html. It is not there, so this file will be created in the current location. Current location means what? C online classes. So what is this file? What is the content I want to have into this file? What content I want to write into this file? Right, first let us write this. I'm commenting all these reading operations. Right, I'm going to write writing operations. Control V. Right. So what I need to do here? This is the one. So what is this statement is going to do? It is tries to open a stream with this file. Is this file is exist in my hard disk? No. If you see online classes, if you see the online classes folder, this file is not there. My html.html, no. There is no my html.html, right? No, but file output stream, if it is not there, it creates it. After creating it, it opens a stream, right? Now what I should do into this file? What I want to do into this file? I want to write. What is the method which is given for us to write it? What is the method which is given for writing the data? Write method which takes the data in the form of what? Integers, 10. Now let's see what it is going to do. Execute it. Simple. Create object that will open a stream and use the method for writing. Same way, whatever I did, but it is good. It can write only one character at a time. Now let's see whether the file is created or not. Here, my HTML. Can you see this? Let me remove it. Oh. So many windows. Stacked. So I think it is generating here. Above 8 is going to generate that file. See that? Is it generated? Right? Now let me open this. Open with edit plus. What do you have? Oh, nothing is written. Why nothing is written? 10. Okay. Okay, got it. Why it is not written? Got it. The problem is with the text which I am writing. ASCII value of 10. No. If I pass 99, what is going to do here? Pass 99. Compile it. Write it. It is showing it is modified. My HTML.html is modified. You want to write it. See? C you have. Right? Yes or no? You have a C. Now if you want to write ASCII values, I am passing 97. What you can see there? Right? Let me run this. Compile and run. Open the my HTML. It is showing me it is modified was. Oh, where is that modified? Yes, A. Right? 97 means what? A. Now this is what? Very simple operation. So what is my intention here? I want to read. So this is the class which I want to use for reading this file, and whatever I read I want to write to this file. So what I need to do here? What I need to do here? See here what I'm going to do. What I need to write into this? I. Very simple. What is going to do here? Now see the logic. What is this logic? Do you understand what I did? One output stream object which is used to write, one input stream object which is used to read. So first I am reading from a file. After reading from a file, I am as it is I am writing to what? One more file. F_write. What is the meaning of this? F_write? Write to some other file. Okay. And again read it until this reading is completed. Read character by character and write it to one more file. Okay, simple. I am not doing anything. It is continuous while loop. In this while loop, performing reading as well as writing. fin.read reads the data. F_write writes the data. Yes or no? I'm not writing any miracle here. It's not a big code. One simple reading and one simple writing operation. Let us compile this. It's fine. It's completed very fast. So this is the actual text which is there inside that file. What file? Index.html, and it is written to what? my_html.html. Right? Now if you want to see, actually this HTML file should not be opened with what? Editors. It should be opened with the browsers. Right click on this, open with the browser. See, you cannot see the content, but it is the same. It has given you what? 3 different windows. Content is not written because the content is from different files. Right? Or if you want to do some special reading and writing, okay, we do what? Not this one. I want to read from a.java, and I want to write it to what? temp.text file. Temp.text file. Both are from the current location. A will be from the current location, and temp also will be from will be created in the current location. Is there any temp? No, right? There is no temp.txt. No. So let me compile and run. Fine. Compiled and run. Very fast it is generated. See here, temp.txt. Open it. Same. Right. Now for your confirmation, let me change the file name. I'm going to change this file name from a.java to addition.java. Right. So I'm reading from addition. I'm writing to the same temp. See, it is showing you temp.txt is modified. Yes, why it is not? Temp.txt. And you have all the content of what? Addition class. Very simple, right? Very simple. Yes or no? Now, this is fine whatever we discussed. So nothing is there. So as I told you, opening a stream with a particular class and write the data to through that stream or read the data from that stream is very simple. That what? Creating an object for that particular class. And if it is input stream or output stream, if it is input stream, call the read method. If it is output stream, call write method. Right? Very simple. I did not do any new thing here. Just I have shown you the API. According to that API, I have performed these operations. Right? Now my basic question here is, and very interesting question. Now, whatever the operations, reading operations and whatever the writing operations I have performed, I am using the files. But these files are not common input sources or outputs destinations. What is the common input source we have? What is the common input source generally we use for our Java programs? Keyboard, keyboard. Source I'm asking, device. And what is that destination we always write the data? Console, right? But what is that class which is used to read the data from a keyboard, and what is the class which is used to write the data to a console? Is there any classes given? Keyboard reader, keyboard input stream. Have you seen such kind of class? No. There is no class which reads the data from what? Keyboard, which is given actually, like keyboard input stream or keyboard reader. Or you have not given any class like explicit class to write what to a console writer or console output stream. Then how can I perform these operations, reading from keyboard and writing to a console? Standard streams, right? These are the two common devices for Java programs where we always take the data from keyboard and to which always we are trying to write. Till date we have did the same thing. We have written the data to what? Console only. But is there any classes Java people has given? Such kind of file output stream or file input stream, is there any class given? Keyboard input stream class? No, there is no class given for you. Keyboard input stream class is not there. Then how can I perform these operations? How can I perform the operations for reading the text from a keyboard directly and writing the text to a console? Right, now till date you are using, no, not correct. Till date we are using system.out.println. Now what is this program is going to do now? What is this output, this while loop is going to do now? Can you say what is this while loop is going to do? Whatever the scanner class you said, it is 1.5 class. It is not there in the initial releases. Now what is my program is going to do? Can anybody tell this? This while loop, this simple while loop. I'm not asking in what loops means. That is going to print whatever is there inside account.java. Where it is going to print? It is going to yes, that is one correct answer. No, actually whatever is there in the account.java, I am trying to read and I am trying to write it into two locations. What are the two locations? One is system.out. See here what I am trying to write into the system.out. System.out. And in the same I am going to write the same content to what? File.write. So two different destinations. System.out is going to write the data to what? Console, and file out.write f out is going to write the data to what? To a file. So I am performing two writing operations but on two different destinations. One is onto a console. This one is going to write it to a console. This one is going to write it to a file. Let's see. So what is the text I have in my temp? This is what public class addition I have. Let me run this. See, is the content is written to console? Yes. Is this content is written to console or not? Yes, right? And let me check my temp.txt. This is temp.txt. This text is also modified. See there. So what is this system.out? What it is doing? System.out.print. What it is doing? It is writing the content to what? A standard device, a physical device, a standard output called as what? Console. And this one is writing the content to what? A device called as file. Now that is what just example I am giving here. But I want what is the internal meaning of what? System.out and println. So just my question is simple. I want to write a data to file so that I have created object for what? File output stream. Now it is very clear. I want to write to a file called as temp.txt so that I have created file input stream, and by using this method I am writing it. Right? But where is the object I have created to write the data to what? This one. To what? My console. What is that object I have created to write the data to what? Console. No object I have created. Then how it is performing this operation? That is important task. That is important thing for me. Right? Very, very important point of view question. No. Object is required. It is not simple. What is print method? Print here. What is print? Print is a method. If you want to call a method of a class, what is required? Object is required. Then from where this print method is from? This is a method. Print is a method. And I am passing what? Integer data to that print method. But if you want to call the method of a class in Java, you require object. Where is the object I have created to call this print method? That is the question. Right? Do some research on this. Very important concept. Right? So how the data is written, how the data is writing to a console. And at the same time, how can I read the data from a keyboard directly? Right? So search for these two things, and we'll continue our session tomorrow.